Okay with it. Like, I think sounds and videos are okay. If it is not okay, please let me know. Are they okay with it? Sounds and video? Is there any lagging of the video? No? Thank you for that. Thank you very much. Thank you very much for the comment. Okay, this is start. So now we are going to do our theory part physics today. So you have to maintain another separate book. You have to write the note relevant to basic mathematics in another book. So you have to maintain a separate book for physics. And okay, it is better to use a single rule book rather than a double rule, rather than square rules for them. Okay, physics. I think you have done some part of physics in your oral science syllabus. So now tell me, what is about physics? What do you know about physics? And according to that knowledge about physics, knowledge in physics, can you guess or can you tell me what is this subject? What is about physics? What is physics? What is about physics? Can anyone guess? Day-to-day activities. Yeah. Another explanation? Yes. A very good one. But actually, physics means, actually physics is the science that we are actually that is used to investigate about the absolute truth of the universe. Actually, physics is the science that is used to investigate about the absolute truth of the universe. So when we are investigating the absolute truth, we have to deal with natural phenomena. Sometimes we have to deal with matter and matter and energy. Yes, actually the entire universe is made of matters and energies. I think you will learn those things today. The entire universe is made of matters and energies. And so that is a simple explanation about the universe. The entire universe is consists of matters and energies. Therefore, discovering about the universe means we have to study about matter and energy. And what is the correlation, what is the interrelationship, or what kind of interactions is available between matter and energy. Therefore, physics is a science that is used to investigate about matter and energy and their relationships with it. Because that is a science that is used to investigate about the absolute truth about the universe. Therefore, this is very, very important science. So you cannot just remember the theories in physics. You have to understand. Otherwise, you cannot understand the absolute truth of the universe. Okay, so this is something like a religious thing. But actually, now we are investigating about that thing. When we are studying about physics in future, you will learn a lot of things about the universe. Okay, now those are very, very interesting parts for you. And yes, okay. initially we know there were only about 3 dimensions, height, length, and width. Okay, so initially we have dealt with 3 dimensions. Now, in physics, we will deal with more than 3 dimensions, but those are not in our A-levels. But after your A-levels, if you are studying physics in your higher studies, then you will learn those kind of theories. Those are very, very interesting part. So actually the physics is a science that is used to investigate the absolute truth of the universe. Therefore, in simple word, we can say physics is a science that is based on matter and energy. Matter and energy. Is that clear? If it is clear, please raise your hand. Because the reason is the universe is made of matter and energy. The entire universe is made of matter and energy. That is the reason we call the physics is a science that based on matter and energy. Is that clear? If it is clear, please raise your hand. Okay. Then actually physics, if we consider about physics, we can divide the physics into 2 main branches. Actually, there are a lot of branches today, but we can divide the entire physics into 2 main branches. First one is classical physics. Other one is modern physics. Actually, classical physics is based on the theories and hypotheses which are founded or which are introduced by Sir Isaac Newton. Okay. Actually, Sir Isaac Newton is the father of classical physics. Classical physics is based on macro level applications. Macro level applications means those are day-to-day applications. So we can investigate about the motion of a object, and we can investigate about some conversations of energies, some heat energies. We can investigate about some macro level. Macro level means if we can observe those phenomena, that then we can call them as macro level applications. Okay. If we can feel or if we can observe them using our 5 senses, then we call them as macro level applications. Yes, this is first class. This is the first class of physics. This is the first day of physics. Therefore, in classical physics, there is based on macro level applications. Macro level applications. Macro level applications means if any phenomena, if we can observe any phenomena using our 5 senses, then we call that is a macro level application. Micro level means that is a opposite word of macro level. But micro level. Micro level means we cannot observe those things using our 5 senses. Micro level means that is a very, very small level. We can observe that level using Microsoft Word. Sometimes we cannot see that level. We can just assume. Okay. So we cannot observe a nuclear optic. Can you observe an electron? Can you observe a nuclear? You cannot observe, no? You cannot observe, but theoretically we can build a theory according to the assumptions too. Therefore, some micro level applications we cannot observe it. But in macro level application, we can observe those phenomena. Therefore, the classical physics is based on those kind of macro level applications. So there is a introduction of this physics. And so after doing some actually, as the physics develop as a science, then scientists observe some phenomena that cannot be explained using classical physics theories. So normally some phenomena, there were some phenomena that cannot be explained using classical physics theories. And therefore, they had to assume, or they had to build a new branch of physics that is called modern physics. So modern physics basically based on micro level applications. Micro level applications in the universe. So this is based on the macro level applications of the universe, and this is based on the micro level applications of the universe. And actually, you know, the matter is made out of nucleus. In the nucleus there are protons and neutrons, and around that there are electrons. Those kind of micro levels parts we cannot observe. Okay, therefore we cannot determine the interrelationship between those particles using macro level physics. Therefore, there is another branch of physics that is called modern physics. The modern physics basically based on micro level applications. Sometimes you may hear this. Sometimes you may know about quantum physics, particle physics, then nuclear physics. All of them are sub-branches of modern physics. All of them are sub-branches of modern physics. And because all of them are based on micro-level applications. Therefore, physics basically can be divided into two main categories. There are a lot of subcategories, but two main categories. One is classical physics, other one is modern physics. So classical physics is founded by or introduced by Sir Isaac Newton, and that is based on micro-level applications. Most of the theories in classical physics were introduced by Sir Isaac Newton. Then there were some observations of phenomena that cannot be explained by the theories of classical physics. Therefore, there's another branch of physics which is used to explain those kind of phenomena, especially in micro levels. That is called modern physics. Right? So there are a lot of sub branches with it. As some examples, we can say about. So Puti, this is unit 1. Okay. Please listen to the theory unit Puti. This is unit 1. We are discussing the unit 1. Okay. Okay. Please listen to the unit Puti. Listen Puti. So there are two main branches: classical physics and modern physics. Is that clear? syllabus එකෙන් පිට කිසිම දෙයක් උගන්වන්නේ නැහැ. හරි. කලින් ඒවා syllabus එකේ තිබ්බේ. syllabus එක කියලා කියන්නේ syllabus එකේ maths part එකත් ඕගොල්ලන්ට අවශ්‍ය knowledge එක දෙන්නේ. අනවශ්‍ය කිසිම දෙයක් උගන්වන්නේ නැහැ. හරි. So this is in your syllabus. හරි. Okay. Then actually in our physics syllabus, most of the units are based on classical physics today, not modern physics. Though most of the units are based on classical physics instead of 2 units. One is matter and radiation, other one is electronics. Instead of those 2 units, all the units are based on classical physics. Therefore, we are going to discuss about classical physics. Okay. In classical physics, actually, as I explained you earlier, physics is a science which is used to investigate some phenomena of the universe. Therefore, in classical physics, there's a procedure. There's a procedure of investigation of a certain phenomenon. Suppose you observe some observation. Now you are going to investigate the reason for that observation. Now, please listen to me very carefully. This is very important thing. Suppose now there's a grass. There are some grass here. You know what is the color of grass? Normally, what is the color of grass? What a part of the grass? It is green, no? It is green. So you observe. There are some. There's an area of grass. This part is in yellow color. All the other area in green color, but this part is in yellow color. Now you see this on the observation, no? You observe this observation. So you need to know what is the reason for this one. What is the reason for this one? So if you want to investigate about this observation, you have to follow a set of procedure. If you want to investigate this observation according to the classical physics, we have to follow a set of procedures. That is called scientific method. Scientific method. Therefore, our next topic is scientific method. Initially, we have discussed about physics. What is physics? Then we have discussed about the branches of physics. Now, we are going to discuss about classical physics, because instead of 2, actually almost all the units in yellow syllabus are in classical physics instead of 2 units. In classical physics, there is a procedure, there is a method to follow when we are going to investigate about observation. That is called scientific method. Therefore, our third topic is scientific method. In scientific method, we have to follow a set of procedures when we are going to observe, when we are going to investigate the observation. So I can explain that thing using this incident. Now there is a ground of green grass, but in the ground you observe a certain area which is in yellow color. Okay? You observe a certain area which is in yellow color. And so now you are going to observe, you are going to investigate the reason, the scientific reason behind this observation. So the first thing you have to follow, you have to note down the observation. You have to note down the observation. Observation. What is the observation? You have to clearly mention that thing. You have to clearly mention the observation. Okay. What is the observation? So in here, the observation is normally, you know, the grass are in green color, but some part of this ground is in yellow color. So that is observation. So you have to mention the observation first. Because when you are investigation about an observation, you have to clearly mention it. You have to clearly understand about the observation first. Therefore, first step is the observation. That is observation. So once you observe a phenomena, then you can go to the investigation. And therefore, the second thing is you can build a hypothesis. Hypothesis means assumption. You can assume a reason to it. You don't know exactly what is the reason for that. Still, you may do not know what is the reason. But you can build an assumption. According to your scientific knowledge, you can build an assumption. We call it as a hypothesis. The second step means building a hypothesis. Building a hypothesis. Hypothesis means that is the assumed reason for this phenomena. According to your scientific knowledge, you can assume a reason for this phenomena. And now, according to our scientific knowledge, I'm going to assume that is because of lack of sunlight. And so that is my hypothesis. Lack of sunlight. So that is the reason for seeing this part in yellowish color. Is that clear? That is my assumption. I don't know whether it is correct or not. Okay with it? I don't know whether it is correct or not, but according to my scientific knowledge, I assume that would be the reason. Is that clear? I need responses from everyone today. Then, and one. Now we have assume some part to assumption about it. So we need to determine whether my assumptions are correct or not. To check that to check that one, I need to do some experiment. Therefore, the third step is doing some experiment. Experiment means that experiment is I'm going to proceed this experiment to check whether my assumptions or hypotheses are correct or not. Actually, I do not need to confirm my assumptions with it because I don't know whether they are correct or not. Actually, I need to check whether they are correct or not. That is the reason I'm going to perform an experiment. Therefore, the third step is performing an experiment to check whether the assumptions are correct or wrong. Correct or wrong. And performing an experiment or a set of experiments. Okay, is that clear? Clear, Nathan? Okay. Okay. Yeah. So after doing some experiment, I can justify my assumption. Okay, justify why if I need any changes, then I can make those changes with it. Therefore, after doing some experiments, after doing several experiments, I can build a correct or accurate theory. Accurate theory according to my assumptions, and after performing some set of experiment, then I can accurately identify what would be the real reason behind this. Once I identify what is the real reason behind this, then I can build a theory. Then I can build a theory. Then I can build a theory. But I will explain it. Then I can build a theory. මේක පුතේ අර ඕගොල්ලෝ අර කරා වගේ අර පොල් කාර්ය කරේ මොකද්ද මේ මොනවද අපි කිව්වේ observation experiment plus conclusion එහෙමම ටිකක් ඒ වගේ නමුත් ඒකම නෙවෙයි හොඳේ ඒකම නෙවෙයි හොඳේ හරි. Then I can build a theory. Building a theory means I can use my hypothesis and the observations of the experiment. Then I can adjust my assumptions and then identify what is the real reason. When I identify the real reason, then I can introduce, I can introduce that real reason as a theory. As a theory, make a theory question. So, suppose this assumption is correct, then I can build a theory. If the sunlight, this is an example. Okay, this is an example. So my observation is this one today. There is a grass ground with a glass down. You know, glass ground is a green one, but I can observe a certain area in a yellowish color. That is my observation. I made the observation. Then I assume the reason would be the lack of sunlight. Then I am going to perform an experiment. Then I will choose a good ground. A good ground means all the area are in green color. Then I can take a certain container and I can cover a certain part of this ground. Using a container. And I can keep this covering up to several days. Then I can remove this covering and check the color of the ground. If it is in green color, make sure this container should be a black color one. Okay, otherwise if it is a transparent one, then sunlight will be there. Therefore, sunlight cannot pass through this container. Okay, so after keeping this container up to several days, then I can remove the covering. Once I remove the covering, if I observe this part in yellow color, then my assumption is correct. My assumption is correct. If it is not, my assumption is wrong, then I have to build another assumption and do another experiment. Is that clear? තේරුණා තුෂාර? If it is clear, please raise your hand. පැහැදිලිද කලින්ද? හරිද? අනිත් අය තේරුණා නැද්ද? Yes, you can build a theory. This is free for everyone. Huh? Actually, when you are going to do your PhD or something, you have to do. You have to build a theory. Huh? Otherwise, you cannot take PhD if you have enough money. Otherwise, you cannot take a PhD. So you have to build your own theory. Okay. So if this observation is matched with my assumption, then I can make a theory. I can make a theory. If actually, if the sunlight is not enough, then the green color of the ground can be converted into yellowish color, or you can build some advanced theory. So this part is building a theory. And building a theory. Then the last part is prediction. Actual predictions means sometimes you have to modify your theory according to later observations. Sometimes, suppose this kind of things is happening. Suppose this. Sometimes you are going to apply some fertilizers onto this ground. If you apply a fertilizer, then you can observe the same observation. Sometimes the concentration of fertilizer is high, then this grass can be appeared in yellowish color. Therefore, the same observation can be occurred due to another reason. So that is observed, actually that was observed after developing this theory. Therefore, after developing a theory, you have to do again and again. You have to do experiments again and again. You have to look into the factors that can affect to this observation, that can change the theory. You have to do, or you have to make sure the accuracy of your theory timely. And you have to do that part of it. Therefore, you have to do observation, or you have to collect data, and you have to make sure whether your theory is correct, or there has to be made some modification to the theory. Therefore, you have to timely, you have to do the experiments again and again. You have to correct some data again and again. Then you can do some modifications to your theory. And sometimes the modifications can be done by another person. The initial theory was found by a scientist, but after observing some different observations, some modifications were done by another scientist. Those kind of things will happen. And therefore, the prediction part means you have to predict, or you have to make sure whether your theory is accurate or not. And according to the current data, you have to predict about your theory. And so that is the procedure of investigation. That is a procedure of investigation about the phenomena according to classical physics. This is called scientific method. What is the method? What is the method today? Scientific method. Scientific method. So those are the five. Those are the 5 steps of scientific method. And those are the 5 steps of scientific method. තේරුණාද දුෂාන? මේ ගැන තාඩක් කවුවක් හරි අහන්න තියෙනවා නම් මොකක් කාට හරි තේරුම් නැත්නම් මොකක් හරි ආසයක් අහන්න පුළුවන් නම් අහන්න පුළුවන්. questions තියෙනවා. Do you have any questions regarding this method? Do you have any questions? Questions තියෙනවා? No. Is that clear? තේරුණාද? I need your feedback. පැහැදිලිද? Okay. Then we have discussed about physics today, initially physics. Then the branches of physics, we have discussed about branches of the physics. Then among those 2 branches, actually we are going to discuss about classical physics today. Therefore, we have discussed about scientific method. Scientific method is the procedure about the investigation about a phenomena in classical physics. Scientific method. Okay, that is about the introduction part of the physics, the introduction part of the physics. Okay, so after these 3 subunits, the introduction part of physics is over. Okay, method introduction part එක ඉවරයි physics වල. මේ introduction part එක ඇතුළේ මොන හරි තේරුම් නැති දැන් තුන ගන්න. scientific method එක අනිවාර්යයෙන් ඔයගොල්ලෝ පාඩම් කරගන්න ඕනේ. You have to study this one. Okay? Scientific method අහන්න පුළුවන්. Is that clear? Yeah. Now we are going to discuss about the next part, units and dimensions. Units and dimensions. Units and dimensions. Okay. In physics, actually, we have to take lot of measurements. Therefore, first of all, we have to discuss about the measurements. So, unit and dimensions based on those kind of measurements. And therefore, first lesson of physics is based on measurements. Now, Suppose now this is a cuboid. If you consider about this kind of object, it is very clear there are a lot of things that can be measured. Yeah? You can measure the width. You can measure the height. You can measure the length. What else? What are the other things that can be measured in this object? Tag again. What are the other things that can be measured in this object? Yeah, the mass. Very good. The mass. The mass can be measured. What else? The mass of the object can be measured. Yeah, weight. Mass was weight weight. How? The volume. Yes, very good. The volume. Weight. Sorry, H W L volume. Yes, volume. What else? Yeah, volume, capacity both are same. Density, yes, density. Not both are same, but density, yes, density. Density. Area, surface area. Surface area. Therefore, these kind of measurements can be taken regarding this object. So, today, if you are given a system that has a measurable properties, such kind of system is called a physical system. Physical system. Therefore, we can consider this one as a physical system. Therefore, physical system is a system which has a measurable property or properties. If any system has a measurable property or properties, then we call that kind of system as a physical system. Is that clear? So this is a physical system. This is a physical system. Yeah. So this is the first topic of the unit and dimension lesson. Physical system. Then physical quantity. Physical quantity. Okay. As you mentioned earlier, height, width, length, area, mass, weight, volume, density, those are the measurable properties in this physical system. Like you know. Now it is very clear, height, length, width, area, mass, height, volume, density, those are the measurable properties. Those are the measurable properties in this physical system. Those kind of measurable properties are called physical quantities. Physical quantities. Therefore, physical quantities are the properties in a physical system that can be measured, Putin. Therefore, physical quantity means it is a measurable property in a physical system, Putin. Therefore, mass is a physical quantity, Weight is a physical quantity, volume, density, area, height, length, width, all of them are physical quantities. Therefore, those are the measurable properties in a physical system. Is that clear? Physical quantity. Measurable properties in a physical system. Okay, then we have discussed about physical systems. And physical quantities. Now we have defined physical quantities. So after the definition of physical quantities, now we are going to classify those physical quantities. Now we are going to classify those physical quantities. Now, the next topic is classification of physical quantities. හොඳට අහගෙන මම කියන දේ හොඳට අහගෙන මම කියන්නේ මොකද මම නම් ඔයගොල්ලෝ නෝට් එකක් දෙන්න printer නෝට් එකක් දෙන්නේ. හරිද? ඒ නිසා හොඳට අහගෙන කියන්නේ. ඔයගොල්ලෝ තේරෙනවද කියලා අර නෝට් එක ලියලා කාලේ කරන්න ඕනේ දෙයක් නේද? හරිද? ඒක නෙමෙයි. මේ පාඩම එච්චර අමාරු පාඩම නෙමෙයි බොහොම විශේෂ පාඩමක්. හරි. The classification of physical quantities. Today, the classification of physical quantity can be done according to several criteria. And physical quantities can be classified according to several criteria. The first criteria is according to the way of taking the measure. What is the first criteria, Pute? According to the way of taking measurement. According to the way of taking measurements. And what is the meaning of that? Look at this one. Again, we can go to the first example. What was the first example today? This cuboid. So what are the physical quantity? What are the physical quantities in this cuboid? Tell me. Physical quantity means the properties that can be measured. The properties that can be measured. Those are the physical quantities. Now tell me what are the physical quantities related to this cuboid? Height. Yes. Length. Width. Yes, very good, Pute. Kandi. Area. Mass. Density. Weight. What else? Volume. Those are the physical quantities related to this physical system. Look at those physical quantities, Putin. Some physical quantities like height, mass, length, width. Those physical quantities can be taken directly without any calculation. Without any calculation, you can take those physical quantities directly. Okay? You can take a meter ruler or you can take a balance. Then you can measure the mass and the distances. So those physical quantities can be taken directly. But look at this one. Can you take the volume directly? No. You have to measure H, L, W separately and you have to multiply 3 of them. Then you can measure the volume. Can you measure the density directly? No. You have to take the mass. You have to calculate the volume. Then only you can take the density. Okay? Yes, density is a measurable property. Volume is a measurable property, no doubt about that. But they cannot measure directly, Pute. That is the thing. They cannot measure directly. But height, mass, those kind of things, those kind of measurements can be taken directly. Therefore, the physical quantities can be categorized according to the way of taking measurement. Some measurements can be taken directly, while some measurements cannot be taken directly. They require some calculations for it. They require some calculations. Okay, but they can measure, they can be measured, but the thing is, they need a calculation. Is that clear? Clear, Natusan? Okay. Therefore, according to the way of taking measurement, according to the way of taking measurements, the physical quantities can be classified. Mainly can be classified into two categories. Two categories for it. First category is fundamental physical quantities. Fundamental physical quantities. And the second category is derived physical quantities. So their fundamental physical quantity means those are the physical quantities that can be measured directly. That can be measured directly. Derived physical quantities means that cannot be measured directly. That cannot be measured directly and they require a calculation. Require calculation. And therefore, those are the two main categories of physical quantities according to the way of taking measurement. Pute. Instead of these two categories, there's another one that is supplementary physical quantity. Supplementary physical quantities. Pute, in supplementary physical quantities, we categorize angles. We categorize angles in supplementary physical quantities. There's a reason for it. There's a reason. Radian is units for it. Those are not physical quantities. There are only two supplementary physical quantities. One is plane angle. Other one is solid angle. plane angle and solid angle. I will teach you what is the reason to have this extra category. That's a reason for it. That's a reason I will teach you. Okay? All right. Therefore, there are two main categories and one extra category that is called supplementary physical quantities. Only the angles, only these two physical quantities are categorized under this category. Therefore, in supplementary category, there are only two physical quantities, which are plane angle and solid angle. Plane angles means if the angle is in the plane, we call it as a plane angle. Normally, we measure plane angles. Solid angle means if there's a 3D condition. Suppose you need to measure the angle between them. So this is a three-dimensional angle. The three-dimensional angles are called solid angles. Solid angles means three-dimensional angles. Plane angles means two-dimensional angles. This is a two-dimensional. The angle is on a plane. On a plane. Okay. Solid angle money is star radian. This star radian means there is a unit of solid angle. And radian means the unit of plane angle. Units and physical quantities are two different things. Okay? Now I am discussing about physical quantities, not about the units. Okay? Unit is that okay? Star radian and radian means those are the units of those angles. Yeah. Okay. Reason So what is the reason for this one? Well, what is the reason to have a supplementary physical quantity? You know, according to S equal R theta, according to S equal R theta equation, can you subject theta? Can you subject theta, Pute? Tagga subject karne theta? If you subject theta, what is the answer? If you subject theta, what is the answer? Tagga again. If you subject theta, what is the answer? S over R. Now, can you please substitute the units of S and R to this equation? Tagga substitute. Can you substitute units of S and R to this equation and take the unit of theta? Take the unit of theta. If you want to take the unit of theta, you have to substitute the unit of S and R. If you need to take the unit of theta, you have to substitute the unit of S and R and subject the unit of S and R. What is the unit of theta? If you substitute the unit of S and R, what is the unit of theta? You know S is a length of the S means S is an arc length. Arc length is measured by meter or centimeter, anything that is a length. Radius also a length. Therefore, both are measured by meter or centimeter or in the same unit. Therefore, meter to meter will be cancelled out. Therefore, theta should not have a unit. The angle should not have a unit. But it has a unit. It has a unit of radian. not only radian, but also their degree, no? According to the definition of this one, the angle should not have a unit, but it has a unit. Now there's a contradiction. Now there's a contradiction. So due to this contradiction, actually the angles can be measured directly. Look, the angles can be measured directly. You don't know any calculation to measure angle with it. Angles can be measured directly. Although angles can be measured directly, there's a contradiction in the unit. According to this equation, the angle should not have a unit, but it has a unit. So due to this contradiction, although the angles can be measured directly, it is not categorized under fundamental column. Angles can be measured directly. Therefore, it is not a derived physical quantity. We do not need to any calculation to measure an angle with it. Therefore, it is not a derived physical quantity. Therefore, angles cannot be categorized in this column. Angles cannot be categorized in this column. Therefore, angles are categorized under separate column put it. That is called supplementary physical quantity. Supplementary physical quantity. That is the reason to have another extra physical quantity type. Did you get my point? Okay, I'll explain. Okay. Mga parang mulai kami explain करना. Supplementary means you means the name. The name. Yeah, that is a name, but the name is supplementary means actually it is something like extra one. Supplementary skill additional therefore they cannot categorize this one under this column and this column. Therefore, it is categorized as a extra. That is the reason it is mentioned as supplementary. Yes, it is additional. Okay, look at this one. So according to the way of taking measurements, the physical quantities can be categorized mainly under two categories. One is fundamental physical quantities, other one is derived physical quantities. So fundamental physical quantity means the physical quantities that can be measured directly. Something as length, mass, those are categorized under fundamental physical quantities. But some physical quantities, when you're doing measurement, but some physical quantities cannot be measured directly with it. Those are required some calculation to measure. As an example, volume, density, weight, those can be categorized. Those can be categorized under this category. But as I mentioned earlier, instead of these two categories, there's another one, supplementary physical quantities. Under that quantity, under that physical quantity type, okay, there are two physical quantities. Those are angles. One is solid angle, other one is plane angle. And solid angles means Three-dimensional angle. Plane angle means two-dimensional angle. And the reason to have this subcategory is this one. You know, you can measure angles directly. Is that clear? Angle kelima manina baydu ogalanta. Puluwanda baydu. You know, angles can be measured directly, no? Therefore, it should be categorized under this category. It should be categorized under fundamental category. No? Is that clear? It can be, actually, it should be categorized under fundamental category. But it is not categorized under this category. What is the reason? The reason is this one. According to a sequel theta equation, if you subject theta, theta is equal R is over R. So if you substitute their units, S is measured by meter because it is a length. Arc length is a length. Radius also a length. Therefore, the units is meter over meter. Therefore, unit of theta. If you find the unit of theta, the answer is there is no unit. There is no unit. No. Meter to meter will be cancelled out. Therefore, theta doesn't have unit. Is that clear? Theta out of the unit tag පැහැදිලිද? තේරුණා තුස්සන්නේ? If it is clear, please raise your hand. But the angle has a unit, Naputi. It has a unit. One unit is radian, other one is a degree. Therefore, angle has a unit. Actually, angle should have a unit because otherwise the taking measurement is not meaningful. Actually, angles are used to measure the amount of rotation. So, if you need to measure an amount of something, definitely there should be a unit. Otherwise, how can we express that thing? Therefore, there should be a unit. Otherwise, there is no meaning of angle. Therefore, we have to assign a unit for them. That is the reason we have assigned radian and degree. But the thing is, if you assign a unit, then there is a contradiction. Contradiction means there's a contradiction. According to one scenario, the angle has a unit. According to the other scenario, angle should not have a unit. So there's a contradiction. Due to this contradiction, the angles are categorized separately. They are not categorized under fundamental. They cannot be categorized under derived because it can be measured directly. Therefore, we cannot categorize the angles under derived physical quantities. So, due to these reasons, angles are categorized separately to these two categories. That category is named supplementary physical quantity. Is that clear? Thank you. Thank you. Now we can discuss about fundamental physical quantities. Fundamental physical quantities. Today, actually, the fundamental physical quantities means those are the physical quantities that can be measured directly. That can be measured directly. Actually, there are only 7 fundamental physical quantities in physics. There are only 7. And ගොඩක් නෑ. අපිට ගොඩක් measure කරන්න බෑ. And what are the 7 fundamental physical quantities? You have to remember these 7 today. You have to remember these 7. First one is weight. The second thing is mass. Third one is time today. Time like measure කරන්න පුළුවන්. No need of derivation. Fourth one is temperature. Sometimes we call this as thermodynamic temperature. දෙකම එකයි. Fifth one. Fifth one, electrical current. Electrical current. Sixth one, the amount of substance. Amount of substance. Seventh one, luminous intensity. So those are the 7 fundamental physical quantities. There are only 7 fundamental physical quantities in physics. Those are the 7 fundamental physical quantities: length, mass, time. Those are the main 3 length, mass, time. Then temperature, electric current, amount of substance, and luminous intensity. Those are the 7 fundamental physical quantities in physics. Is that clear? You have to remember this one. Yes, Putha, yes. That's Candela. Putha, derived physical quantities means actually we use fundamental physical quantity. We use fundamental physical quantities to derive physical quantities. So if you need to determine volume, volume is length into length into length. No, it is 3 length. That is a volume. If we consider about density, density means mass over volume. Mass is a fundamental physical quantity. Volume is equal to length into length into length. Therefore, derived physical quantities are derived using fundamental physical quantities. Therefore, derived physical quantities are the physical quantities that cannot be measured directly and that is derived by fundamental physical quantities. Is that clear? Clear or not, sir? Those are the fundamental physical quantities go there. So derived physical quantities. So derived physical quantities means those are the physical quantities that cannot be measured directly. That cannot be measured directly. Cannot be measured directly. And we can use fundamental physical quantities to derive derived physical quantities. As an example, area is equal to length into another length, no? Width means length. Those are two lengths, width and height of two sides are length. Therefore, it is a length into another length. It is into another length. Okay? Then volume. Volume means this is a length, this one also a length, this one also a length. Digat is a length. Therefore, volume means it is a length into a length into a length. Length into length into length. And therefore, derived physical quantities are derived using fundamental physical quantities. If we consider about density, density is equal mass over volume. Mass is a fundamental physical quantity. Volume is a derived physical quantity, but it is derived using fundamental physical quantities. Therefore, we can write this one as length into length into length. Therefore, any derived physical quantity can be expressed using fundamental physical quantities because they are defined or they are calculated using fundamental physical quantities. Is that clear? ඕනිම derived physical quantity එකක් පොතේ අපිට fundamental physical quantity කීප එක يعني combination එකක් විදිහට දක්වන්න පුළුවන්. හරිද? fundamental physical quantity කීප එක combination එකක් විදිහට දක්වන්න පුළුවන්. තේරියද? උනාද? Then we have discussed about supplementary physical quantities put there. Then now we can classify physical quantities in second criteria according to second criteria. So this is the first criteria put there. Classification of physical quantity according to the way of taking measurement. According to the way of taking measurement. So we can do the same thing. We can do the categorization of physical quantity according to the properties of those physical quantities. According to the properties. So this is the second criteria. This is the second criteria. The classification of physical quantities according to the properties. Second criteria, classification of physical quantities according to the properties. According to the properties of them. Now, according to the properties of those physical quantities, we can classify them into another three categories. Today, some physical quantities have magnitude. magnitude, a direction, and a unit. Okay. Physical quantity means that is a measurable thing. That is a measurable thing. So if you measure a physical quantity, definitely it should have a magnitude. No. Definitely it should have a magnitude. 7 part. No. If you physical quantity means that is a measurable property. So if you take a measurement, that measurement should have a value. No? That measurement should have a value. So if it has a value, that means it has a magnitude. Definitely it had a magnitude. So instead of that magnitude, some physical quantity has a unit put in. So if you consider about length is measured by meter. Okay. So length, suppose you are going to measure a length from here to here. Once you measure this length, you can express it as a 10 centimeter. So 10 means that is the magnitude. This is the unit. This is the unit. Therefore, some physical quantities, actually no, not some physical quantities, all the physical quantities should have magnitude. Other than the magnitude, some physical quantities has a unit. Some physical quantity has a unit. Other than the unit, some physical quantity has a direction. Direction, that is a special property. You know about such kind of physical quantities. Can you give me some example? Physical quantities having those three properties. Can you give me some examples? I think you have experience in your oral syllabus. Yes, velocity, displacement, those are some measurable properties. Yes, those are some measurable properties. They have a magnitude and a unit as well as a direction. Yes, as well as a direction. Therefore, those physical quantities are called vector quantities. මොනවද අපි කියන්නේ? Vector quantities. Vector quantities. We can give some examples today. Velocity, normally we call it, we can call it ms minus 1. So this is the magnitude, this is the unit, and there's a direction. There's a direction, we can mention it. Displacement, meter. So this is the magnitude, this is the unit put in, and it has a direction. And so those are called vector quantities. Vector quantities. Is that clear? තේරුණා තුස්සන්න? Then some physical quantity puthe, they do not have direction. They have only a magnitude and a unit. Some physical quantity have a magnitude and a unit only. Magnitude and unit only. Okay. Give me some example. Yes, speed, mass, time. Then what is temperature? The mass, time, temperature, speed. Mass, time, temperature. What is speed? Weight එක ගන්න බෑ. weight එක මෙතනට එන්නේ. Weight has a direction. Is it directed into the downward direction? the weight always directed into the downward direction. Therefore, weight is there. Weight is a vector quantity. It is a force. But mass is not a vector quantity. Other than these two categories, there is a special category. They have a magnitude only. They have a magnitude only. They do not have a unit even. Can you give me some examples? Can you give some examples, please? Maybe you don't know. Refraction index. Refraction index. Refraction index. Then relative humidity. Relative humidity. Then this efficiency. 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 I think you know this one. Efficiency. Efficiency do not have does not have a unit. It has a magnitude only, no? It is a percentage, no? It has a magnitude only. The efficiency has a magnitude only. Make a efficiency. Then another one is coefficient of friction. Coefficient of friction. Those are some examples of physical quantities that has a magnitude only. Relative atomic mass, yes, relative atomic mass, those are correct. Yes, relative atomic mass is correct. Okay, these two categories, these two physical quantities do not have a certain direction. Therefore, both of them are called scalar quantities. Scalar quantities. Scalar quantities. Scalar quantities. This is called vector quantity. Both of them are called scalar quantity because they do not have a certain direction. Is that clear? Ready? Now that is all about physical quantities. That is all about physical quantity. Now, in our next class, we are going to discuss about units. Units. Then after, we will discuss about dimensions and dimensional analysis. And make a bohom vegan and pulwa. Make a bohom vegan and pulwa. Now, no. Percentage is not a unit. Percentage is not a unit. I didn't get you, Pute. That means did I conduct another class before this one? Yes, we have done in 25th, no? No, not 25th, sorry. 5th of April. 5th of April. That is our first lesson. After that, that is our first lesson. First lesson means that is not a lesson, that is an introduction lesson. Then, after that, the following Thursday, we have done the first lesson. that is about trigonometry. I think all are shared. If you want to have the recordings, then I will send them again. I will send them again. And we have done 2 lessons. First one is introduction lesson. There is not a theory lesson. The second one is maths lesson. And ඒක මම කියා දෙන්න පුතේ. ඒක මම ඉන්ස්ට් කරනකොට කියා දෙන්න. හරි. මම ඉන්ස්ට් කරනකොට කියා දෙන්න. හරි. තව ඉන්ස්ට් අපි කරේ නැහැ නේ. මම ඉන්ස්ට් කරනකොට පිළිවෙල කරන්න ඕනේ. හරි. ඒක කියා දෙන්න මම. Okay. What's about today's lesson? Did you get all the things? Son? Thank you, Uday. Thank you. Thank you for the feedback. Did you get all the things? Yeah. Thank you. Thank you, Uday. Thank you. Thank you. Okay. නෑ මං කියන්නේ මේ මෙතඩ් එක හොඳයි මට නිකන් මේ තේරෙන විදිහට මොකද වේගෙන් යන්න පුළුවන්. දැන් මේ ටික අපි ලියන්න ගියා නම් මාර වෙලාවක් යනවා. හැබැයි මේක අනිවාර්යෙන් ලියන්න ඕනේ. ඒ නිසා නෝට් එක ඕනේ. ඒ නිසා මේක printed note එකක් විතර මම මේක ඔයගොල්ලන්ට මම share කරනවා. ඔයගොල්ලෝ දැන් මම use කරපුවා මම එව්වේ දැන්ට ඔය මගේ 26 ක්ලාස් එකේ හිටියා 27 ළමයි දෙන්නේ. ඒ ළමයි දෙන්න නෝට් එක. කලින් ඔයගොල්ලොත් එක්ක හිටියා කලින් ලෙසන් එකේදී. ඒ දෙන්න නෝට් එක. මේ ඒක තමයි මම ෂෙයා කරේ. මම ලස්සනට ලියලා තියෙනවා මාරම පිළිවෙලට ලියලා තියෙනවා. මේ මම ඒක එක්සැම්පල් එකක් ෂෙයා කරේ. ඔය වගේම නෝට් එකක් තමයි මම print කරලා එවන්නේ. හරිද? ඔයගොල්ලෝ දැන්ට ඔක use කරන්න පුළුවන්. හරිද? මේ හැබැයි මම මේක print කරලා දෙනවා. print කරලා දෙන්නේ මේ ඔයගොල්ලන්ට මේක use කරන්න exam එක දක්වාම use කරන්න පුළුවන් විදියට. හරිද? මේක මහා ලොකු පාඩමක් නෙවෙයි අමාරු පාඩමක් නෙවෙයි. Making පුතේ exam එකට questions ඉන්නේ MCQ questions දෙකයි. MCQ questions දෙකයි. MCQ questions දෙකකට මේ අපි ලොකු time එකක් waste කරන්න ඕනේ නැහැ කියන එක තමයි මගේ මතය. හරි. ඒ නිසා මම කැමති ළමයින්ට මතක හිටින්න මේක ලියා ගන්න පුළුවන් නම් හැබැයි මේක මහ ලොකු අමාරු පාඩමක් නෙවෙයි. ඒ නිසා මේක අපි දැන් මේක අපි ලොකු කොටසක් මේ ඉවර කරේ නේද? හරි. ඒ නිසා මේක මම හිතන්නේ effective. හරි මම ඒක share කරන්න. හරි. Thank you, Putin. And I will share it. I will share. Yeah. Okay, then we can complete today's class, Putin. Our next class will be on next Saturday. If I can conduct another lesson on next Thursday morning, I will let you know. I will let you know if I can conduct another extra lesson in Thursday morning. I will let you know. Most probably I can do. Okay, most probably I can do. Therefore, please allocate your time Thursday morning from 5:30 a.m. to 8 a.m. 8 a.m. Have it? Have it? So if I cannot conduct, then definitely there is a normal class today. There will be a normal class in Saturday. Okay. And next Monday means day after tomorrow, I will post your tunes today. Therefore, next Monday or Tuesday, only. मैं very well हर Monday कराएगा बोलो, मैं Tuesday कराएगा ना, मतलब वो बोला कि नहीं mistake आता है करना तो नहीं. मैं therefore, if I cannot post the tunes on Monday, I will definitely post the tunes on Thursday. Okay, Tuesday. So, if you actually, I need your addresses. Therefore, please mention your address very correctly in the Google Sheet and mention your working phone number. Have working phone number. Okay. Thank you. All right. So we can conclude today's class. Everyone, good night. Have a good day. Yes. 7:30. 7:30. Get up with it.